Today we're taking a look at section 5-2 and we'll be doing some sample problems from the textbook, and we'll begin working on page 207 with number 8. So in this section we're working with probability distributions, and what we have to do first is we have to be able to identify whether or not we have a probability distribution. So our first task is to take this column here and check to see if the sum of probabilities is equal to 1 or very close to 1. Sometimes with rounding what we find is that our sum will either come out to 0.999 or 1.001, which would be close enough based on rounding. Sometimes that occurs. So otherwise, if we get something larger or smaller than larger than the 1.001 or smaller than the 0.999, then we do have a problem and we don't have a probability distribution. So the first thing we want to do is we want to add up the numbers we have, the probabilities, and I'm getting a 1.001. So yes, this is a probability distribution. The second part of the problem, if we find it is a probability distribution, we're asked to find the mean and the standard deviation of that probability distribution. Okay, if you remember, the formula for the mean is the sum of the x's times p of x. So we want to take each value of the random variable, in this case from 0 through 5, and multiply it by its corresponding probability. And you can see I've already have the table set up, so I'm ready to do that. So 0 times 0.659 is going to give us a 0. Our next one, 1 times 0.287 is 0.287. 2 times 0.05 would be 0.10. 3 times 0.004 is going to give us a 0.012. 4 times 0.001, 0.004. And the 0 plus means that we have a number that's a small positive number, but essentially it is a 0, so we just simply multiply 5 times 0. Alright, so to find our mean, we need to sum up this column that we just created. So I'm going to add those up. Okay, and I'm getting, for the sum of the column, 0.403. Now, because we have whole numbers, we want to round this to the nearest tenth. Remember, we want to carry one decimal place beyond what our random variable is. So in this case, we would get 0.4. Now, our formula for the standard deviation, we take the square root of the sum of the x squares times p of x minus the mean squared. Okay, we've got the mean. Okay, and always when you're calculating, use the most exact value you have. So when I go to put this, I'm going to use, when I go to fill in the formula for the standard deviation, I'm going to use the 0.403. So, but in the meantime, I need to calculate the x squared times p of x. So going down my column of random variables, I want to multiply or square each one of these, so that's the easy part. 16 and 25. Now I want to multiply this column by the p of x column, and I've got that highlighted in green to make sure I stay where I'm supposed to be. Okay, 4 times 0.05 is going to be 0.200. 9 times 0.004, 0.036. And 16 times 0.001, 0.016, and 25 times 0 is 0. So again, we want to add these up. So I'm going to add my numbers in that last column. And I'm getting 0.5 0.539. Okay, so what we want to do is we want to find the square root. Okay, that sum is 0.539 minus our mean is 0.403. Notice I'm using the 0.403 rather than the 0.4 that is my answer for the mean. We only want to round in the last step to keep our answers as accurate as possible. So I'm going to take the square root of 0.539 minus the 0.403 squared. Close that off, and I get 0.613, etc. So for the purposes of this problem, my two answers would be 0.4 for the mean and 0.6 for the standard deviation. Okay, let's move to a new page and we'll take a look at number 10. And let me transfer this table. We have fun ways to flirt. We have email and P of X 0.06, in person, and this is 0.55, and we have instant messaging. I'm just going to say IM, and that's 0.24, and text message, I'm going to put TM, and that is 0.15. So we have the different ways to flirt, and the table, and we look at it, and the question is, are we looking at a probability distribution? Okay, the problem with this is we don't have a random variable that has numerical values. So we have a big problem. There would be no way we could multiply email times 0.06 and come up with a value, or in person times 0.55. So actually we can stop at that point. We don't even need to add up the probability. So we want our x to be numerical values for the random variable. So in this case we don't have numerical values for the random variable, so we're done with that table. That's the nice thing about the ones that don't meet the property. Okay, and number 12, we have happiness. We have groups of people aged 15 to 65 are randomly selected and arranged in groups of 6. The random variable x is the number in the group who say that their family and or partner contribute most to their happiness. Okay, so this time we do have numbers, which is good. And the numbers range from 0 through 6. Okay, and our probabilities, we start with a 0, then we have 0.003, we have 0.025, 0.111, 0.279, 0.273, and last but 0.208. Okay, so we do have numerical values, so that is met. What we need to check then is the sum of our probabilities. We want to make sure that they add up to 1 or almost exactly 1. So we want to add that second column. Okay, and I'm getting 0.999. And again, due to rounding, it may be come up to be 0.999 or 1.001. So in those cases, we say it is a probability distribution. Okay, now I'm going to do this one a little bit differently from the last one. It turns out you can do the table like I did, or we can use the calculator. So I'm going to go to the calculator, the TI-83 or 84 plus. They both work the same way, basically. Notice some of the newer ones have a few screens that are a little bit different, but for the most part they work the same way. And what we're going to do is we're going to use the stat button. Let me clear this. We're going to go to the stat and edit. Okay, and what we want to do is we want to put the values of the random variable in the first column. So our x's go in the first column. So we want to enter 0 through 6. So 0, 1, 2, 3, 4, 5, and 6. Then in the second column, we want to insert the probabilities. For the 0 plus, we just put in a 0, and we continue on down. Okay, so we have all of our probabilities. Let's see, it looks like I'm missing one. I have 003, 0.025, 0.111, 0.279. Oh, okay, I got to enter. Okay, now I've got them all. Alright, so now we want to go to Stat and Calc, and we're going to do one variable stats because we're only working with an X. So I'm going to enter there. And I want to put in L1, comma, L2. So I want to make sure again that it's using the first two columns. Okay, so what do we come up with for our mean? And this is actually our mu in this case. So we have 4.6. And for our standard deviation, and you'll notice it's only a population standard deviation given here, so that gives us a good hint that we are working with a probability distribution. Okay, so it's 1.029, so we'd round that to 1.0. So let me go back here. So our mean was 4.6. Our standard deviation was 1.0. So now you have two ways to do the problems dealing with a probability distribution. Once you've identified you have a probability distribution, you have the option of doing it in the table format like we did number 8, or with the calculator like we did in number 12. So those are the two ways we can do that. And you may want to do the problem the longer way and then check it with the calculator. Or if you're running short on time, you may just want to do it with the calculator. Okay, let's move on to number 16. It says use the range